Welcome to Lesson 3, Creating Your AI Worker's Home. Subtitle, Provisioning Your First Virtual Machine. Today, your AI worker gets its own computer. Up to this point, we've talked about what a complete AI worker is and why it needs a permanent environment. Now we're going to build that environment. By the end of this lesson, you'll have a real Linux machine running in the cloud 24 hours a day, 7 days a week. This machine will eventually hold every major component of your worker, from its runtime to its security configuration. This is where the build becomes real. A virtual machine is a computer created inside a larger physical computer. Cloud providers operate massive data centers filled with physical servers, which they divide into smaller, isolated computing environments that customers can rent. Each environment behaves like its own computer, but it doesn't sit on your desk. It lives inside a professional data center and remains available even when your personal computer is turned off. You could technically begin building an AI agent on your personal computer, but there's a problem. Your computer was not designed to be the permanent home of an autonomous worker. You close the lid or you lose Wi-Fi and the agent disappears. A real AI worker needs an environment that is continuously available, remotely manageable, and separated from your personal files. We need a reliable production architecture, not just an experiment. There are many providers that can host a virtual machine, platforms like DigitalOcean, AWS, or Google Cloud. The provider is not the most important part of this course. The architecture is. Regardless of who you pick, the core resources remain the same. You need a Linux operating system, processing power, memory, storage, a stable internet connection, and secure administrative access. I'll use one provider consistently for clarity, but you can follow along with any standard Linux VM. For this course, we're going to use Ubuntu Linux. It is widely supported, well documented, and compatible with every tool we'll install. When choosing your image, make sure you select a current Ubuntu long-term support or LTS release. LTS means the operating system receives security and maintenance updates for an extended period. This makes it the stable, reliable choice for a machine that will remain online indefinitely. You do not need an enormous server to begin. Since our worker will use external APIs for reasoning, the VM doesn't need to run massive models locally. It's only responsible for the runtime, tools, knowledge, and services. A practical starting configuration is 2 virtual CPUs, 2 to 4 gigabytes of memory, and roughly 40 to 60 gigabytes of solid-state storage. This gives us the capacity we need without paying for infrastructure we don't use yet. The virtual CPUs provide the processing power for the OS and services, while RAM allows multiple processes to run without competing. Storage holds Hermes, the Obsidian Vault, and your logs, while the IP address gives us a way to connect. Later in the course, we will place a secure Cloudflare tunnel in front of the services we expose. But for now, the public IP will allow us to establish our very first administrative connection. Cloud providers will also ask you to select a region, the physical area where the data center is located. Choose a region reasonably close to you or your users. The exact location isn't critical, but it's important to stay consistent. The important thing is choosing a stable region and recording where your machine is located. This will become the permanent geographic home of your AI worker. Before we create the machine, give it a meaningful name. Infrastructure is easier to manage when every machine has a clear identity. Avoid generic names like Server 1. I often give my AI workers human names because each one has a specific role. Stan might be a consultant, while Kim manages knowledge. For this course, we'll use Alex Agent as our default. The name itself isn't what matters. What matters is building with intention. Next, the provider will ask how you want to access the machine. Whenever possible, use an SSH key rather than a reusable password. Passwords can be guessed or leaked. SSH keys use cryptographic authentication to prove you're authorized. SSH keys are significantly safer when stored and protected correctly. We'll cover the connection process in the next lesson, but if you have a key available now, select that option to begin securing your foundation. Now, review your configuration. Ubuntu LTS, 2 vCPUs, 2 to 4 gigs of RAM, solid-state storage, a nearby region, and SSH key authentication. Once everything looks correct, go ahead and create the virtual machine. When you clicked Create, the provider allocated resources in a real data center. Within a few minutes, you went from having an idea for an AI worker to owning the environment where that worker will live. It created an isolated virtual computer, installed the OS, configured the network, and assigned an internet address. You now own the foundation where your AI worker will call home. This machine is now yours. It is an always available remote computer, isolated from your personal files and daily activity, ready for the intelligence we're about to add. Once the machine is running, locate its public IP address, the numerical location used to reach it over a network. Save this address somewhere secure. We'll use it in the next lesson to connect using SSH. The IP address itself isn't a secret, but you should still avoid publishing unnecessary infrastructure details. Never share your private keys, passwords, or service tokens with anyone. Cloud infrastructure is normally billed monthly or hourly. A small starter VM is usually quite modest in price. Review the monthly estimate before you finalize, and keep an eye on any extra charges for backups or traffic. Start small. You can always increase resources later if your worker needs more capacity. Good infrastructure design means selecting the smallest reliable environment that meets your current needs. Creating an internet-connected machine also creates responsibility. This server should follow basic security principles. Use SSH keys, avoid root, and keep your software updated. Security is a layer we build into every part of this architecture. We will implement these protections progressively. Do not attempt to configure everything at once. We are building a secure foundation, and that means following professional standards from day one. Before moving forward, avoid these common mistakes. Don't choose an unusual Linux distribution just to be fancy, and don't use weak passwords when SSH keys are available. Most importantly, don't delete the server after this lesson. We're just getting started. We're building a long-term home for your worker. Every future lesson will build on this same machine. Treat this infrastructure with the care it deserves for a production-ready system. Now, I want you to pause the lesson and confirm that you have completed each item before moving forward. If your machine is online and you have your IP address recorded, you've hit your first infrastructure milestone. Take a moment to verify everything. Ubuntu is installed, your specs are correct, and your machine status shows running. If you're ready, we're about to move up the stack to administrative access. Our virtual machine is now complete. It is the permanent foundation beneath everything else we are going to build. Next, we need to establish secure administrative access and prepare the server for the Hermes runtime. In the following lesson, we will connect to the machine using SSH, explore the Linux environment, and create a safer administrative structure. We're moving from physical foundation to operational control. Your AI worker now has a permanent home. It has computing power, storage, and a stable network location. It can remain online without depending on you. In the next lesson, we'll turn this into a secure environment. I'm Brian Jones, and I'll see you in the next lesson as we take command of our new infrastructure. Let's keep building.